Okay, so welcome back, and now we're going to talk about the definition of an infinite limit. And so there are three types of infinite limits that we're going to discuss. There's infinite limits from the left, infinite limits from the right, and then of course infinite limits that approach from both sides. Okay, so there's the three types. Okay, just like there are three types or two types of limits. Okay, finite limits. Okay, so here we're going to talk about three types of infinite limits. You could look at three types of finite limits as well. So there's a parallel there. So now I'm going to go through. Now again, you're going to want to pause if you're going to take notes or look in the textbook. But there's a lot to be written down here. Since I'm on a whiteboard, I'm going to erase things when I jump around. So basically there are going to be three types. I'm going to start with the left, infinite limits from the left. There are two cases in that. Then there are two cases to consider for infinite limits from the right. And then there are two cases to consider when you're talking about infinite limits from both directions. Okay? Excuse me. So let's start with from the left. So here's case one. So infinite limits from the left, we have a function. We want this function to be defined on an open interval of the form b comma a. Okay? So everything between, this is our a value, the one we're approaching. So again, we're approaching from the left. I says if the values of f of x increase without bound, as the values of x, again from the left, approach the number a, we say the limit as x approaches a from the left is positive infinity. So again, increases without bound. Okay, and we would write it this way. Now, the other case is, what if it decreases? What if the values decrease without bound as the values of x for x less than a approach the number a? We say the limit approaches a from the left is negative infinity. And so we would write it this way. Okay, that's it. So that's infinite limits from the left. And that would be number 2 in this case. Okay, now let's go to the next type, which is infinite limits from the right. So I'm going to change things here. So this will be from the right. And then our interval is going to be now a comma b. And we'll put this back to I. And we'll put this back to increase. This is going to be greater than. And of course this is going to be positive again. Positive. So now, if we're talking about infinite limits from the right, then again, we have a function that is defined at all values on the open interval from a to b. Okay, now we're talking about approaching a from the right side. It says, if the values of f of x increase without bound as the values of x, again from the right, approach the number a, we say the limit as x approaches a from the right, is positive infinity. And this is the way we would, from the right. So this is the way we would write it. Now, again, in the second case, what if it decreases without bound? So again, if the values decrease without bound, as the values of x approaches the number a, we would say the limit as x approaches a from the right is negative infinity, and we would write it this way. So again, pause, make sure you write this down, okay? And that takes care of the two cases in which you would have an infinite limit when you're approaching from the right. Okay? Now, what about from both directions? So this is going to be infinite limits where for all values in an open interval, where x is not equal to a. Okay, so we would say two-sided. So we would call this two-sided infinite limit. Okay? It says let f be a function defined at all values in an open interval. So I'm going to have to rewrite this a little bit. All values in an open interval containing a. Oops, hold on. And x not equal to a. So it's defined at all values of x except x equal to a in an open interval containing a. So now, case 1 is if all the values of f of x increase without bound as the values of x x not equal to a approach the number a, we say the limit as x approaches a is positive infinity. And that's the way we would do it. Again, so if the values of f of x increase without bound as the values of x approach the number a, we say the limit has, as x approaches a, is positive infinity. Okay? And then likewise, for the second case, we would change the fact that we would look at if it decreases. So if the values of f of x decrease without bound, as the values of x, x not equal to a, approach the number a, we say the limit as x approaches a is negative infinity, and we would write it symbolically like that. And those are the 6 cases. So 3 types, 2 cases in each type. And that is the definition of infinite limits. Okay. Have a great day.